Now we're going to continue talking about projectile motion problems and begin to solve for the range. Okay, we're going to use the same example we were just using, with a projectile being launched at 30-degree angle to the horizon with an initial velocity of 100 meters per second. Now keep in mind that from our last segment we just talked about calculating time in the air, which we calculated to be 10 seconds. 5 seconds to get up, 5 seconds to get back down, for a total of 10 seconds. So now let's focus on the range. Now the range, again, is the distance traveled in the x direction. And just remember that we have both an x component and a y component of our velocity. And which one of these two velocities is now going to determine the distance traveled in the x direction? You should have answered that it was the x component. Now it's pretty simple because the x component of our velocity is not changing at all. Okay, there's no acceleration in the x direction, which means that our velocity will remain constant throughout the whole process. So we're going to use some basic trigonometry to solve for this. In this case, cosine of 30 is equal to adjacent over hypotenuse, or x over 100. So cosine of 30, you should have that memorized, is 0.9. So 0.9 times 100 gives us x, which in this case will be 90 meters per second. So now we know that our projectile is traveling at a constant velocity of 90 meters per second, and it will travel at that velocity for a period of 10 seconds. So because it will be traveling 90 meters per second for 10 seconds, we know that it will travel a total distance of 900 meters. And that's our range. And that's really all you have to do. It's as simple as that. And again, no equations.